We're going to pick up where we left off on our lab motions of the Earth-Moon system. And now we're going to talk about some various kinds of motions that the moon makes, and remind you about Earth motions as well. So remember, there are two distinct kinds of motions that I've talked about this semester that the Earth makes: rotation and revolution. Rotation is spinning on an axis, or in some cases an imaginary axis. The Earth rotates once every 24 hours on its axis, and the moon, it turns out, also rotates once every 27 1/3 days, so quite a bit slower than Earth's rotation. What about revolution? Well, the revolution is the movement of an object around another object, an orbit. The Earth orbits the sun once every 365 days. The moon orbits the Earth, and interestingly enough, it orbits the Earth once every 27 1/3 days. The same exact amount of time it takes the moon to make one rotation. This fact is why the same side of the moon always faces the Earth. Let me show you with a little cartoon. Here we have the sun and the Earth in the positions that we've seen before. And what I've done is I've put the moon in its first quarter position, and I've landed a rocket on it. We sent a rocket from the Earth, and we landed on the moon in this position. And the thing is, we're not going to move the rocket. The rocket is going to stay exactly where it is, and the moon is going to continue on its journey around the Earth. 3.5 days later, the moon is moved, but that side of the moon is still facing Earth. 7 days later, we're in our full moon phase, but that part of the moon is still facing the Earth. Here we are in our waning gibbous, our third quarter moon, our waning crescent, but the same side is still facing us. So you can see that the same side of the moon is sometimes illuminated and sometimes it's not. This is an interesting explanation to the difference between the dark side of the moon and the far side of the moon. We have dark and light, and we have near and far. The dark side of the moon sometimes faces us, and if I go backwards, sometimes the light side of the moon faces us, and sometimes we have both, right? But the far side of the moon, which is the opposite side as the rocket, never faces us. The far side is the side that's always facing away from us. And the near side, the side that the rocket's on, always faces us. This is actually a very stationary orbit called a geocentric orbit. It took 27 1/3 days for the moon to go around the Earth. Did it rotate as well? Well, sure. Let's go back. Now look at just that rocket. Here's that rocket, and it made one complete rotation. So that's how the same side of the moon always faces the Earth. Its period of rotation and period of revolution are the same. But now, hold on to your hat, there's something else, the lunar month. And the lunar month is one cycle of phases, which means new to new, or full to full, or first quarter to first quarter, a whole set of lunar phases. How long does that take? Well, I'm sorry, it is not 27 1/3 days. It's actually 29 1/2 days. So what in the world is going on? Well, we have to do one more diagram, so get out a fresh piece of paper. On this diagram, I want you to put the sun, the moon, and the Earth across the top. And I want you to have the sun pretty far away from the Earth and moon this time. Still not to scale, but a little bit better than what we've been showing. In the position I've shown, the moon is a new moon, and I've shadowed it to emphasize that. Remember that the moon goes around the Earth once every 27 1/3 days. But there's another thing going on here, and that is that the entire Earth-Moon system is orbiting the sun. So over time, this entire system moves, as shown by this red arrow. And 1 month later, 27 1/3 days, this entire system might be down here. So this moon went 360 degrees, and it took 27 1/3 days. So the moon made one rotation, and it went around the Earth one time. But let's take a look at the shadows now. Sunlight is now coming from this orientation, and the circle of illumination on Earth is in this position. It isn't the same as it was up here. And on the moon, the actual circle of illumination is going to be in the orientation of this red line. So this is not a new moon, even though I'm showing the shading as a new moon because I'm trying to make a point. It's actually a waning crescent. Sometimes it's called an old crescent. So in fact, we have to go a few more days to get back to the new moon phase so that that circle of illumination is in the right orientation. That is where our extra few days comes in. And then we're back to a new moon. So it takes just a few more days to go through the complete lunar cycle from new to new or full to full. Your lab manual has names for these two kinds of months. The one that takes only 27 1/3 days is called a sidereal month. And the one that takes 29 1/2 days is called a synodic month. So I hate to throw vocabulary words at you. You can write these down and have them available when you take your test. But there are two different names for these types of months. You are going to be asked in lab to explain the difference. So hopefully this helps. In your lab, activity 2 covers this idea. There's a little introductory portion here that asks you to look at this diagram. Hopefully this diagram looks somewhat similar to what we just drew. In this first month, the rays from the sun are coming across the page, and in the second month, the rays are coming down at an angle like this. The questions end at number 9, where, as I said, it asks you to explain the difference between these two kinds of months. Before the actual questions, notice that there's a little paragraph that explains the difference between these two kinds of months. Finally, we finish up with the idea of eclipses. When something eclipses something else, it gets in the way of it. And there are two kinds of eclipses. There are solar eclipses and lunar eclipses. And solar eclipses is when the moon gets in the way of the sun. And these are the ones that cause a lot of attention because they're incredibly fantastic to see. Sometimes you might see a partial eclipse, sometimes you might see a total eclipse. They are really spectacular. I accidentally happened to see one once, and it really was breathtaking. What happens is that the moon passes in front of the sun, and the moon's shadow hits the earth. It doesn't hit it all the way around the earth, just in one part. And as the earth spins, it tends to make a line or a track across the earth, a path. So this can only happen during one type of moon phase. What phase is shown here? This is a new moon phase. Now you might ask, well, if we have a new moon phase every month, why don't we have a solar eclipse every month? And that's because the earth, moon, and sun have to be exactly in a straight line for this to happen. And that is not the case every month. The other type of eclipse is a lunar eclipse, where the earth gets in the way of the sun hitting the moon. In this case, the earth's shadow hits the moon, and the earth is a lot larger, so the shadow is larger as well, and it covers the entire moon. Now in this case, the moon doesn't necessarily disappear, it actually turns sort of a red color. And you maybe have seen these. And what phase of the moon is this? This would be a full moon. And these happen more often than solar eclipses. In your lab, you have a number of questions here about eclipses, and I think I've just about answered all of them. It asks you to make a little sketch of the sun, moon, and earth during a solar eclipse. It asks you to select during which moon phase this would occur. Then it asks you to make a little sketch during a lunar eclipse, and again select during which moon phase this would occur, and then explain why these don't happen every month. Finally, we get to the lab report. Question number 1 asks you to explain how the phases of the moon change during the entire lunar cycle. This is kind of a big question with just 4 lines, so do your best to summarize very briefly. Question 2 asks about these 4 images here, and students have a lot of problem with one part of it. It says, look at the photos, give the name of the phase. Most of you will probably have no problem giving the name of the phase after having gone through the lab. It also says to give the time of day when the picture was taken. And that puzzles a lot of people. But the key is you have to look at what it says at the beginning. It says the photographs were taken when the moon was in the highest position in the sky. So the moon was directly overhead when the picture was taken. So for example, this one I hope you recognize as the full moon. And I've already explained that the full moon is directly overhead at midnight. So this one would be full moon and midnight. I think you get the idea. Number 3, once again, asking you to explain the difference in your own words between a sidereal and synodic month, so you can kind of repeat what you had before. And then in this next question, they're asking you to sketch various positions of the moon. And just keep in mind that the sun is on the left here, not on the right. That's the only mistake I see students make. And then there's a few more questions over here that I think you'll be able to answer. So that's it. I know this was a rather long explanation of the lab, but there was a lot to cover here. I wanted to make sure everybody was really clear on what was going on. I also hope this shedded some insight into what you saw during your moon observation project, and I hope that you never look in the sky again and see the moon in the same way.